Where were you exactly 2,935 days ago? Try to picture the room you were sitting in, the job you had, or what you were worrying about. It's nearly impossible to pin down a single Tuesday from 8 years ago. In that specific window of time, we saw the rise and fall of entire global supply chain crises, the mainstream adoption of electric vehicles, and geopolitical boundaries redrawn across Europe. Whole cultural eras came and went. While millions of human events played out across the globe, one solitary camera sat bolted to a fixture, perfectly still, firing its shutter continuously. Human memory over an 8-year span is a blur of fragmented moments and vague feelings, but this machine captured an unbroken, highly objective record of absolute reality. We are used to time lapses being incredibly easy. You prop your smartphone up against a coffee cup, hit record for 2 hours, and you get a neat 10-second video. Try to extend that exact same process across 2,935 days, and physics quickly shuts you down. A standard lithium-ion battery dies in hours. Consumer-grade camera sensors left open to constant direct sunlight simply burn out. Securing a static angle for nearly a decade requires a constant physical defense against environmental decay. Without intense continuous mechanical intervention, the gear will fail 100% of the time. Getting a camera to survive that long is a staggering feat of engineering long before it ever becomes a piece of art. To compress time, a camera takes a single photograph at a set interval, say every 10 minutes. When you play those individual photographs back at 24 frames per second, hours of real-world time pass by in the blink of an eye. If a shutter fires once every 10 minutes, that's 144 photos a day. Over 2,935 days, it multiplies into 420,000 frames. Storing these raw files requires constantly cycling through terabytes of data across physical hard drives, introducing multiple points of critical failure. All of that high-risk data is eventually fed into rendering software. The program mathematically stitches the sequential files together, squeezing a massive digital archive down into a dense 60-second video file. Every single second of the final output is forged from over 1,000 raw data points. A single fleeting moment of screen time carries the incredibly heavy weight of months passing in the real world. Out in the elements, the hardware faces violent extremes. Across 8 years, a stationary rig is pummeled by sub-zero ice storms, relentless torrential rain, and blistering summer heat waves. This cross-section shows the specialized casing required to defend against those elements. It features internal thermal insulation to prevent heat damage, and weather-sealed optical glass to stop moisture from creeping in and forming mold directly on the lens. To guarantee the shutter never misses a 10-minute interval, the rig requires a fail-safe power grid. Deep-cycle battery backups ensure continuous operation even during weeks of heavy cloud cover when the solar arrays can't draw enough energy. Even if the physical camera survives, the ground beneath it shifts. A microscopic settling of the tripod legs over several years results in harsh, unwatchable jumps when the footage is played back at high speed. Editors use advanced software to stabilize these micro-movements and color-correct the sequence. This involves accounting for 8 years of wildly varying ambient sunlight to ensure the transition between seasons appears seamless. While the physical housing protected the hardware, the software had to reconcile 8 years of shifting earth and inconsistent lighting to create a smooth continuum. After thousands of days of brutal exposure and terabytes of heavy data processing, the technical struggles fade away. What remains is a pure, uninterrupted visual experience. Deep winter snowbanks melt away in a fraction of a second, instantly replaced by a violent spring bloom, which rapidly rots into autumn decay. Years pass in single breaths. Our biology prevents us from experiencing time this way. The human eye evolved to track immediate motion, like sudden predators, violent weather events, or fast-moving objects, leaving us completely blind to slow, macro-environmental growth and decay. This specific piece of engineering acts as a prosthetic for human perception. It accelerates the slow mechanics of the natural world into a speed our brains can finally process and understand. We live in a digital ecosystem built on fast, disposable media. By contrast, a 2,935-day project demands extraordinary patience. capturing a massive scale of physical reality that only reveals itself to those willing to wait for it.